Now we will see the different applications of sine rule and cosine rule. There are mainly 4 applications. First is what we call as half angle formulae. Second is area of a triangle. Third is also area of a triangle, but it is a different formula than the second one. And this third formula we also call as Heron's formula. And the last one, fourth, is what is called as Napier's analogies. So let us go over all these applications one by one. Now in all of these applications we'll be using a symbol S to stand for the semi-perimeter of triangle ABC. So that means S is nothing but sum of all sides A plus B plus C upon 2. So hence we can write 2S is equal to A plus B plus C. So this particular symbol we will frequently use in the remaining formulae and applications. So moving on, here is the statement of half angle formulae. Now to begin with, we consider the half angle formula for sine, that is sine of A by 2 is equal to square root of S minus B into S minus C whole upon BC. Now just to clarify, these formulae are related to a triangle only, okay? So they are applicable only for angles of a triangle and sides of a triangle. Now in order to prove the half angle formulae, we take use of the basic trigonometric identities and then use the cosine rule. So to prove this particular formula, we start off by saying that 1 minus cos A is equal to 2 sine square A by 2. Right, which we know as a basic trigonometric identity of half angle. So therefore, flipping the sides, we can write 2 sine square A by 2 is nothing but 1 minus cos A. So 1 minus cos A can be written as, in place of cos A, we now substitute the expression that we had derived using cosine rule. So that is b square plus c square minus a square upon 2bc. Correct? So therefore on cross multiplying we get 2bc minus b square minus c square plus a square upon 2bc. Correct? So that gives us, now I will write a square as first and minus, keeping all the terms inside the bracket, we will get b square minus 2bc plus c square. Basically all the remaining 3 terms will have their signs reversed. They will become the opposite, whole divided by 2bc as it is. Moving on, therefore 2 sine square A by 2 equals A square minus, now the bracketed term here is nothing but the square of b minus c, the whole square, whole divided by 2bc. Okay. So therefore we can bring the factor of 2 on right side and make it as 4bc. So therefore sine square of a upon 2 is equal to, okay, in the denominator we have definitely 4bc, and in the numerator we can factorize it because it is x square minus y square. So we can factorize as a plus b minus c into a minus b plus c. So therefore this is equal to, now a plus b minus c we can write as a plus b plus c minus 2c. Okay, the purpose behind writing this is that we want to achieve a plus b plus c, which can be replaced by 2s, because here we have to somehow bring in the term of s. Right? So that's the first bracket multiplied by the second bracket is, similarly we can write that as a plus b plus c minus 2b in a similar manner, whole divided by 4bc. So basically from the first bracket we can write 2s minus 2c, and in the second bracket we can write down 2s minus 2b whole divided by 4bc. So therefore we can take 2 common from the first bracket as well as 2 common from the second bracket and cancel out with the 4 in the denominator. So therefore finally we are left with exchanging the terms in the numerator. We'll just write s minus b as the first term into s minus c as the second term whole divided by b into c. So therefore this is sine square of a by 2 equal to s minus b into s minus c upon bc. So therefore if we take the square root of both sides, we will ultimately get the statement of half angle formula of sine of a by 2. Okay. So that's the way we prove this particular result. Now like we have the formula in sine, we have a similar formula in cos. So that is what we see now. Cos of a by 2 is equal to root of s into s minus a upon bc. Now the procedure to prove this is almost similar to the previous one, but with a minute change that instead of writing 1 minus cos a, here we write as 1 plus cos a is equal to 2 cos square a by 2, and we go on simplifying exactly in a similar way. Now we replace cos a with b square plus c square minus a square upon 2bc and adjust all the further terms so that finally we get the required square root. Right? The rest of the procedure is exactly similar to the previous one. And like sine and cos, we have the last half angle result, that is tan of a by 2. Now tan of a by 2 can be written as sine of a by 2 upon cos of a by 2, and we have already proven the results for sine and cos of half angles. So if we write them, we get numerator s minus b into s minus c upon bc whole divided by root of s into s minus a upon bc. So therefore bc terms get cancelled, and finally we are left with the statement of root of s minus b into root of s minus c whole upon s into s minus a. So that is the half angle formula.